So I'm now here. So this is a spectrophotometer. As you can see, it's firstly you set your wavelengths. So when we start, we say go to, okay, and it'll ask you for the wavelength. So we are using 610 nanometers because that's the maximum absorbance for copper in copper sulfate and copper compounds. Copper absorbs at 610 nanometers. So that's what gives you the nice blue color that we know of copper. And so we set it at 610 nanometers. We could do it at 550 or 580, but you're not getting the maximum absorbance. 610 is a good figure to work with, and we just press enter. Okay, so it's now set to 610 nanometers. And so the first thing would be for us to zero this instrument. So we open this little chamber here, okay, and you remove whatever is in this at the moment. So that's not ours, it's someone else's. And you put your cuvette in the first, it must be in the first one, okay? You could even put your cuvette in the second one too, okay? But we'll just work with first one. So we put that in. Because it's blank, it's got no copper in it, it's just got water, it's showing some small absorbance. Now we must cancel that. And so we're calibrating this instrument, so we'll press the 0 to say, without copper there, it must read 0. So you can see the machine has turned into 0 there on absorbance. Now we put in our first sample, which is, so remember, don't forget to always handle at the frosted sides, not the transparent. So that's the transparent side. You can see the light is going, and that's the frosted side. So you can certainly hold it on that side, but don't touch the clear surface. So you set that blank aside, okay, and you put in your 1.1 molar in there. Always close the lid. Okay, so we have done the blank, and we got the absorbance on the blank, and we set the machine to 0. So just like what we did for the blank, remember, we put some water in it, and we put those in the holder. We can do the same thing for each of our other samples, our 0.1, 0.2, 0.3, and 0.4, which is now placed in the spectrophotometer. So now if I close it, then I'll be reading the first one, which is 0.1, and I'm seeing the reading there is 0.110. As the absorbance, I note that down, 110. Then all I need to do is to pull it forward. So sample 2, which is the next cuvette, which is 0.2 molar, and its reading is 0.080. 0.080. And then go to 0.3, which is 0.136, 0.136. We go to 0.4, which is 0.190, 0.190. Okay, take that value, 0.180, 190, that's fine. Okay, so we can only do 4 at a time. So we open that, okay, and we remove at least the first 2 because we still got 0.5 and the sample to do. So we take that off. We can rinse that, okay. And we can take our 0.5 and do it 3/4. Make sure we wipe. The transparent side must be nice and clean. Okay, transparent side nice and clean. You put that there. The next one as well, I'm going to take that off, and I'm going to put my unknown sample. Okay, make sure the transparent side is clear. I'm going to put that in. Okay, and now I'm reading my 0.5. Okay, just 0.105. Sorry, I should have closed it first. So now I'm reading my 0.5, yes, which is 0.582 rather. And my sample is 0.104. Yeah, so now that I've got my calibration curve, I then have to go and analyze the results. And it's possible that if my results are not consistent, I might have to redo the standards and the sample, because there could be some uncertainty, and I can see that these figures just don't look right to me.